Hey folks, and welcome back to Dealing with Physics. Today we're going to go into another math concept. That math concept actually involves triangles. So if you look here, we got some architecture. This particular piece of architecture uses a lot of right triangles, and we care about right triangles today because we're talking about what's called the Pythagorean Theorem. And the Pythagorean Theorem is going to be useful for solving a lot of problems involving things called vectors. So we're moving away from distance equals rate times time into deeper physics, where we have this concept of direction really mattering. We'll get into that more tomorrow. But for right now, let's review some of the tools that we have to try to deal with a more geometric type of problem. And that tool is called the Pythagorean Theorem. A squared plus b squared equals c squared. You probably are familiar with this. So let's make sure we can actually use this. First off, triangles have legs. The legs of a triangle are the two sides that are going to be connected to the right triangle. And there's one side that is opposite the right triangle, or the right angle, and that is the hypotenuse. Okay, so if I'm on the right angle, I'm a leg. If I am on the opposite side, I am a hypotenuse. That's really important because the legs, we're going to call A and B. The hypotenuse I'm going to call C, and A squared plus B squared equals C squared. Okay. Another way of saying that is that leg squared plus leg squared is the hypotenuse squared. So we use these to find missing lengths. That is really what we're going to be doing with this in class. So here's my triangle, and I'm going to start off here, and I'm got my problem. 6 centimeters, 8 centimeters, and I don't know the hypotenuse C. So I start off with writing my equation. A squared plus B squared is C squared. I plug in the values. So the 6, the 8, and the C. Now, a lot of people get hung up on which one's A and which one's B. That is totally irrelevant. A and B are just labels. I could have made A be the 8 and B be the 6. It does not matter or change the problem outcome one bit at all. A lot of people get hung up on it, though. 6 squared is 36, 8 squared is 64. I add those together, and I'm going to get 100. And then I got to use a fancy button on my calculator that I haven't used very much, probably, and that is the square root sign. It looks a little bit like division, but it's very different. Square roots undo squares. Okay, so I got this c squared. To get rid of c squared, I need a square root. So square roots eliminate squares. Turns out that 100 happens to be a perfect square. In this case, 100 is going to become 10 centimeters, and that's going to equal C. Really important, again, to have your units. Don't leave the units off, guys. Next problem here, we got a hypotenuse of 9, a leg of 5, and I'm trying to solve for the other leg. So once again, I plug in. Got to make sure that the 9 goes in where it's supposed to go. I called the missing leg A. It doesn't matter. You could have called it B. It does not matter one bit. 5 squared is 25. 9 squared is 81. Combine some like terms, and then take a square root. Most square roots are really wacky numbers, so just round to the nearest tenths place for what we're doing, and that will be fine. In this case, it's 7.5 centimeters for A. Now, occasionally, you come across ones that are super clean and cool. They're called Pythagorean triples. This is going to be one of those. So we got legs of 3 feet and 4 feet. I'm solving for the hypotenuse. Some of you may already know the answer. Let's go through it anyways. We plug into our frame. We got 3 squared plus 4 squared is C squared. 3 squared is 9. 4 squared is 16. Combine those to get 25. And then square root both sides. That gives you an answer of 5 feet for C. And 3, 4, 5 is one of our Pythagorean triples. those are just sets of numbers that work really well for side lengths. So 3, 4, 5, 6, 8, 10, those are well-known perfect right triangles with nice even numbers. We got a leg of 12 meters, got a hypotenuse of 15 meters. So I plug on in. Again, it doesn't matter. I'm just calling it A. You can call it B. It really doesn't make a difference. 12 squared is 144. 15 squared is 225. The biggest thing to make a difference, to be honest, is putting the hypotenuse in for a leg or the leg in for a hypotenuse. If you're not sure on those, pay close attention. That's where people make mistakes on these. It is usually not the rest of the math, because the rest of the math's easy. You have calculators. They have buttons that can square the numbers. I highly recommend you do learn your squares up to about 25. 25 squared is about as high as you'll ever need to go on standardized tests. But we do have plenty of tests that come up where you need to know something like 12 squared. And if you know it, it's a lot easier than trying to actually fumble with a calculator for 30 seconds. If you can just write, 12 squared is 144, I'm done, and move on to the rest of the problem, you're in a much better shape. Subtract the 144 off. Got 81. Square root of 81 is 9. And in this case, we got 9 meters. Now, I told you that square roots and squares undo each other. So here's an interesting example that I got a hypotenuse that is the square root of 50. It's the square root of 50 long. I'm just going to call my other two sides x because they're the same length. I'm going to say that a and b are both x this time. I could call them both a, I could call them both b, I could call them both x. It doesn't matter. X is just a little more traditional for an unknown. So in this case, a squared plus b squared equals c squared would give me x squared plus x squared equals square root of 50 squared. Now the square root of 50 squared is just going to give me 50, because square roots undo squares, and squares undo square roots. They're inverse operations. X squared plus x squared is 2x squared. I divide by the 2, and I'm going to go ahead and square root both sides to find that x is 5 units. Notice I put the word units here. I didn't give square root of 50 a unit. So we just write a generic units whenever we're doing that. If we don't have a defined unit, it's pretty common in pure math problems to see that. Especially when you're dealing with geometry, you have to have units. Same as most of the stuff we're doing in physics. One last problem, we got an applied one here. We got a 15-foot ladder and it's leaning against a building. The ladder base is 8 feet from the building. I want to know how far up it goes. So I'm going to drop a ladder there. Notice that it makes a right triangle. I'm 8 feet from the building. The ladder itself is 15. The majority of people tackling this problem, I've actually had this problem on tests before. And most people, when they're doing this problem on a test, they mess up what the 15 feet is. They'll actually label the building with the 15 feet, not the ladder. The ladder is a 15-foot tall ladder. Okay. Once you have it laid out, it's really quite easy. You plug into the Pythagorean Theorem. 8 squared 64, 15 squared 225. Subtract off the 64 and take a square root to find that A is 12.7 feet up the building. That's pretty much it for the Pythagorean Theorem. It's really useful for what we're going to be tackling tomorrow and going forward. So be sure to brush up on these skills. If you're not sure how to use a calculator to find the square roots, come see me and we'll work through those. Otherwise, hope you have a great night, and I'll see you in class tomorrow. Bye.